Hi guys, today we're looking at hyperbolic functions, right? So this is our general one. We normally have this one here. Y is equal to a over x, or we can have y is equal to a all over x plus q, and the other one that we can have is y is equal to a all over x plus p plus q, right? So let's start with the first format, or the first one. Suppose our a is 1 and we have something like y is equal to 1 over x, and we want to look at this graph here. You remember I told you that f at x is the same as y, so this is the same thing as to say f at x is equal to 1 all over x. So let's look at our table as usual. So our table will have x and y. This is our table. This is our table here. So suppose we have our 0, minus 1, minus 2, minus 3, and we have 1, 2. So we're looking at our table here. So this means we'll be looking at, let's start with f at x equal to 0. So in this case our domain will be like x can never be equal to 0. X can never be equal to 0, because if x can be equal to 0, it will be undefined, so this one doesn't exist. So let's look at f at minus 1. No, let's start with f at 1. F at 1 when x is 1, so we have 1 over 1, of which is 1, so we have 1 here. F at minus 2 will be nothing but 1 over 2, so this will be 1 over 2. Let's look at f at minus 1. This will be nothing but 1 all over minus 1, and this gives us minus 1. Let's look at f at minus 2. F at x minus 2, we have 1 all over minus 2. This is the same as minus half, so we can look at it as minus 1, and we have minus half. You can look at it, but obviously we will have minus 1 over 3. Okay, so let's look at sketching that graph and see what the result will look like. So because this is a hyperbolic function, one thing you know, this is x, this is y, so we know that the graph will not be defined at x is equal to 0, so it will never touch this line here. X is equal to 0. But let's look what we have. We have 1 is to 1. We can say our 1 is to 1 will be here, and we have 2 is to half. 2 is to half would be here, and we have okay, 2 is to half. So you see, if you were looking at 3, because you see, if you're looking at 3, if you were looking at 3, 3 would be 3 is to 3 is to, our 3 was going to be 3 is to 1 over 3, of which was supposed to be here. So this graph would be like, if you were looking at half of it, let's say we're looking at f at half. When x is half, we'll have 1 all over half. This is nothing but 2, so half would be here. So our graph will look like exactly like this one here. So it will never touch the x-axis, and then it will never touch we'll never have y is equal to 0 as well. So it doesn't touch this one, and it doesn't touch y-axis. So let's look at another. We're looking at another coordinate, of which is -1 is to -1. That would be here, and -2 is to half. That would be here, and the other one would be here. So we can have like something like this as well. So that is our graph as well, where we're looking at something like that as well. So that is our graph. Y is equal to 1 over 2, sorry, 1 over x. So this is our first graph that we're looking at. Let's look at the second one. And now let's look at this format of y is equal to a all over x plus q. So what we want to do now, we want to find out what q does in a graph. What q does in a graph. Okay, so let's look at this example. F at x is equal to 1 all over x, let's say plus 1. Let's see what will happen there in that case. So in this case we're looking at x, we're looking at y, we also going back to look at our table, x and y, our table x and y. So we can have 0, 1, 2, 3, we can have minus 1, minus 2, minus 3. So one thing we know, x can never be equal to 0. So x is not equal to 0. So we got that one. So let's try to look at f at y. F at x is equal to 1. This would be 1 over 1 plus 1. So that would be 2. And let's look at f at minus 2 will be 1 over 2. That would be 1 over 2. So let's look at our calculator. 1 over 2 plus 1. So it's 2 over 3. So 1 over 2 plus 1 is equal to 3 over 2. 3 over 2. So here we have 3 over 2. Then now we're putting at f at 3 is equal to 1 over 3 plus 1. Let's say we have 3 to be 4 over 3. So this is nothing but 4 over 3. So here we'll have 4 over 3. Suppose we're looking at f at x as minus 1. F at x minus 1. This should be 0. This should be 0 because it would be 1 over minus 1 plus 1. So this is 0. So this will be of 0. If you're looking at f at x minus 2 will be 1 over minus 2 plus 1. So now we have minus 1 over 2 plus 1. So this is equal to half. This is equal to half. This is equal to half. So we have 1 over 2. Let's look at our graph here. Let's try to sketch it. Okay, we want to see the effect of q in the hyperbola. So we already know. So in this case we have our asymptote. We already know that our x can be 0. X can be 0, and the other thing. So now we got some asymptote. So where the graph isn't defined. So the asymptote is x is equal to 0. The asymptote means, because you see now we're introducing the asymptote, the way asymptote, it means the graph doesn't touch that line. So in this case we can say that x equal to 0 is an asymptote because the graph will never touch the line x is equal to 0. And the same thing you can say, or you can look at, if you can asymptote, you can say y is equal to 1. So this is our asymptote here. So q is always defined as the y asymptote. Q is our y asymptote. Okay, so if you have an asymptote of which is 1, in this case is y equal to 1, this is y equal to 1, so we can present it as a dotted line. So this line here is y equal to 1. So we're saying that is our asymptote. But let's go back to our, so we can say we have two asymptote, is this one, and also if you're looking at the other asymptote, will be this one here, of which is x is equal to 0. Okay, so let's look at our coordinate. So we have 1 is to 0. No, sorry, we have 1 is to 2. So our x is 1, our x is 1, let's say here is 1, and then we have our y as 2 here, and then we'll have 2 is to 2 over 3. Let's say we have 2, let's say we have 2, and our 2 over 3 will be something like here. So we can have 3 is to 2 over 4, it will be something here. Then if you're looking at this one, will be here. So the graph will be like that. The graph will be like that. Same thing applies if you're looking at our -1, x is -1, but y is 0. X is -1, but y is 0. So that one is here. And we also have 2. We also have 2 is to half. So -2 is to half. -2 and half is to half is here. So you can see if it's -3, it will be something like here. So our graph will look exactly like that one here. It will look like that. You see what is happening? If you're comparing, you can compare it with the first graph, and you can notice what happened, because we're adding 1, because from the original equation, of which was y equal to 1 over x, we said plus 1. So 1 over x, of which is this graph here, you remember it was a graph like this. It was just here, it was just like that, and you can see what is happening. The graph has been shifted or moved 1 unit up, because now we're adding 1, so it's shifting the graph 1 unit up. Let's see some other factors. If we're looking at maybe q being negative, let's look at q being negative, or negative q. Let's look at y is equal to 1 over x minus 2. Okay, so now we're looking at y 1 over x minus 2, and we're looking at our x here, we're looking at our y here, and let's look at our table. Let's look at our table here. Let's look at our table. So what we have, we may have 0, 1, 2, 3, -1, -2, it doesn't matter. Okay, let's look at f. So we already know the asymptote in this case. X is equal to 0, so x can't be 0, and then we can say x can't be 0, and then we can say we have another equation of asymptote that can be y is equal to -2. So that is another asymptote we're looking at here. So let's look at f at x. F at x is equal to 1 over x minus 2. Remember, I told you that f at x and y is the same thing. So let's look at f at x at 1. F at x at 1, that will be 1 over 1 minus 2, and possibly this will be -1. So we have -1 here. So let's look at f at 2. So here we're looking at 1 over 2 minus 2. So what this should be, so we're looking at half minus 2 minus 2. So this is -3 over 2. This is -3 over 2, -3 over 2. So yes, we have -3 over 2. So, and then we can still look at the last one, where we're looking at f at 3. F at 3 is nothing but 1 over 3 minus 2. Let's see what will be that. That will be 5 over 2. That will be 5 over 2. So this is nothing but 5 over 2. You see, this is the same as 2.5, and sorry, as -2 over 5. So this is negative 5/2, and this is the same as 1.5. Okay, so this is minus 5/2. We can now look at 0. So if we put 0, 0 doesn't work, there's nothing there. If you put minus 1, you should get minus 3. If you get minus 2, because if you look at minus 1, f at minus 1, what we're getting is 1 over minus 1 minus 2, that is minus 3. Let's look at minus 2. If you're looking at minus 2, f at x is minus 2. We have f at x minus 2. So we will have, if you're looking at minus 2, so we should have minus 1 all over 2, minus 1 over 2 minus 2. So this will be, so this will be, so we look at minus 2, so it will be 1 over minus 2, 1 over minus 2, minus 2. Okay, yes, so this will be minus, this will be nothing but minus 5 is to 2, minus 5 is to 2. Okay, that's correct. So here we got minus 5 is to 2. Let's look at our graph now. Let's look at our graph here. Let's look at our graph. So we know we have an asymptote of minus 2. So this is our asymptote. Our asymptote is minus 2. We have our x here. We have our y here. And what other coordinate we have? 0, we have nothing. And then we have 1 is to minus 1, which will be here. 1 and minus 1. And what else we have? We have positive 2 is 2 half, positive 2 is to 1.5, so it will be here. And the next one will be 3. So the next one will be here. So the next one will be here. So our graph will look like that one exactly. It will look like this one here. Then if you're looking at the other side, so you have minus 1 is to minus 3, minus 1 is to minus 3, then you have minus 2, that should be minus 2.5, which is minus 5/12. So the other one will look like just like that. The other graph will look just like that. So you can say we have our graph. So this is minus 5/2 as well. So this will be our graph. So you see what happened to our graph because of this negative 2 here from the original graph. So it just shifted 2 units down from the original graph. Okay, so that is how we were looking at this. And you can also maybe look at the graph like y is equal to minus 1 over x. So simply you can get to your graph here, then you put it like that, then you put it like that, and obviously you know that x cannot be 0, so the graph, and then you see if you're putting if you're looking at x is equal to minus 1, x is equal to minus 1, so x is equal to minus 1 is here, x is equal to minus 1, x is equal to be positive 1, so it will be here, just here. Then the next point is expected to be here, the other one is expected to be here. Then you can have a graph just like that. Then you have a graph just like that. Then you see, because now our a is negative 1. So if the graph is negative, it will face this direction, and if it's positive, it will face this direction. If your graph is positive, I mean if your a is positive, if your a is positive from here. So if it's negative, you can expect this. if it's positive, you can expect this one. And I think thank you so much for watching.